Hi, my name's Gardner. In my last demonstration of Watson Visual Recognition, I used positive and negative classes to look at the differences between the same object, one which was perfect and one which was imperfect. And in that experiment, what I found was the confidence factor that something was perfect reduced if it had defects on there. But I also found that the confidence factor that something was perfect reduced as well. So in this demonstration, what I'm going to show is by using positive classes, we can better identify the differences where something is perfect versus imperfect. So let's have a look at this. We've got the visual recognition, which is all part of Bluemix, the DevOps environment. We've got the try service here where we can look at stock images, say for example, identifying breeds of dogs, etc. But we're going to go into the train mode. So click on train and let's have a look at this now. We're going to use our own demonstration here. So let's get started. So on my computer, I've got a number of images. I've been taking photographs of a Lego model for this exercise. So look at the correct images. I've got different views. So if we look at the right view, here it is. And if we look at the different images, all I've been doing is taking a photograph of different angles of that image. I've also got other images as well. So here we've got a picture of the object with a Lego piece missing from here. And we can see on the other side that that's what it should look like, but on this side it's missing. And we've got pictures of the model out of position. So basically the back end has been lifted up so that it looks different to the correct image. So I'll show you the correct image again. There it is, look, so the back end is down. Other images I've got on here, I've got defective images. And what I've been doing is I've been adding marks using paint. So these would simulate a deformity or defect on that object. So if we look at this, we've got this area here that's been coloured in, so that's a black triangle. Here we've got a tiny circle on the front. This one, I've put marks all over the object, and this is I thought I'd try this as a test to help the system identify where potential blemishes could be. And that seemed to make a big difference. And it saved a lot of time as well. Then we've got a line at the bottom. It's got a line at the top, circle at the top, line at the back, a small circle, bottom right. This has got a squiggle. Has got a fine line on the back. So some of these are thick marks, some are thin. Again, I wanted to just see whether or not Watson could identify the difference, particularly if they're hard to see. That's quite a thick line. And then we've got a big circle on there. This one's kind of an off-center marked line. And then we've got the perfect images. So let's load these into Watson and let's start training it. I'm going to start by adding the correct images or the perfect model. So find my images. So correct images, they have to be zip files. So what I've done is each zip file contains a number of images. So we've got front view. You see it's given a name. I can change that if I want, but that's perfect front view. Left view, right view. You can only have 3 in the beginning. I'm not going to add any negative classes. I'm going to call this a Lego model. And now I'm going to click on train. Okay, that's finished. Now I'm going to add the rear view. So your perfect rear view, so I didn't have that before. And again, going to click on retrain your classifier. I don't need to upload any negative images in this exercise. Right, that's done. So we've got 4 positive classes now: left view, right view, rear view, and front view. They're all the perfect examples. And just as a test, we'll see if we can identify those objects. So I'm going to click on my image I'd like to test against. So perfect right view. There we go. It should have a pretty high confidence rating that that's correct. Okay, so it said, yeah, it's got a 82% confidence rating that that's a perfect right view. So it's got the aspect correct. And then we can start training it. So is this correct? Yes, it is. And so we continue. Now I'd like to add the anomalies. So I'm going to add another class. So like I say, it's not going to be a negative class, it's going to be a positive class for the anomalies. Let's select an image. And we'll choose, first of all, a piece missing. Again, to retrain that. Okay, we can see that we've now got a class of piece missing. Going to add the out of position. Let's retrain it on that. Okay, so you've got piece missing, out of position. And then finally, I'm going to add my defective images. Let's be a zip file. Let's retrain it. Again, no negative images. Wonderful. So we've got a number of classifications here now. We've got the perfect images, which have got different aspects. We've got out of position, defective models, piece missing. And now we can start testing the model to see whether it works. Okay, I'm going to select some images. Let's start by looking at the piece missing. There we go. Let's see what it makes of this. So, okay, yeah. It's identified that this is one of the photographs of the piece missing. Now, we're not really kind of testing it much there because that's an image we'd loaded before. But let's see what it can make of a defective image. So there's a mark. Yep, it's identified that this is a defective model. It's 99% confident that that's the case. Click on yes. Let's carry on with the test. Let's see what it makes of a smaller image. We've got the triangle mark on there. There's a fine line. You should be able to see that. There we go. So it's identified as a fine line on there. Defective model. Let's do some tests now. These are all the images that we've already trained the system in. So now what I'd like to do is create some new images, some defective images, and see what happens there. So here's a perfect image which I've put into MS Paint. And what I'm going to do is going to modify this very slightly. Let's see what we can do. Let's add a dot on there. That's a very small dot. Let's make it a bit bigger. There we go. So it's a tiny, tiny little dot there. I'm going to save that and see what happens, and we'll put this into Watson. Now bear in mind that, here we go, there's the file I've saved. There's the image with the tiny little speck on the Lego piece there. Bear in mind that all the images which I'd uploaded on the defective model zip file, if we just look at those, there's nothing on that particular piece. So this is completely different to anything that you've seen before. And what I'm going to do is I'm going to give it a go. So here we go. Results pretty good. It's only a small mark on there, but it's still identified it as being a defective model. Because it's such a small mark as well, it's got a high confidence level that it's perfect as well. So we've got a very close fit there, but it is saying it's got a higher level of confidence that that's defective. That's interesting because we've not, like I say, we've not had any images that have had that mark on there. So it's correct. Let's try a different one. So I'm in Paint again, my perfect image, and this time I'm going to add slightly bigger. Again, it's somewhere where we've never trained Watson on a defect in that area. I'm going to save that and then we'll put it into Watson. So I'm in Watson. Let's add, I've called it wheel, and there you go. You can see the little dot on there. Slightly bigger than what we had on that piece there, but again, it's unique as far as a test. And let's click on open. Here we go. Similar results. Defective model. Yep. And 81% score that's perfect. So yeah, I'd say that's right. So as a final test, what I'd like to do is just add some perfect images. And the more we educate this system, the better it should get. So at the moment it's saying, well, perfect right view. We need some more education as to what's a correct image. So I'm going to go into correct images. There we go. So let's try a left view. There we go. Just final test. Yep, perfect left view. So it knew the aspect. Try again on the right view, because the right view was where we added the defects. Yep, perfect right view. This is the one we've been modifying, so it'd probably say it's going to be defective as well on this. So yeah, it's got 98% probability, but it's a perfect right view. So we're seeing that the figures are starting to change. There's a slight percentage, 66% percentage that there's a defect on there. The more we show Watson, the better it gets. And I think what I'm proving in this exercise is that you've got to show Watson more and more images. The more images it has, the more accurate it becomes. But I think what I have shown is that we can tell a distinction between a defective model and a perfect model, even when we add marks in places that it's not been trained on before. As a final view, I'm just going to show you the JSON output from this. Just bear with me. I'll just move this over. So here we go. We can see that the confidence scores. what we are. We can also see as well that it can tell that this is a Lego model. So it recognizes what it is as far as the class, and it recognized that it's 98% perfect. So I hope you found that useful. My name's Gardner, and thank you very much for watching my video.